Hi guys, here is lesson 99. It is called inverse variation. Some quick review. This comes from lesson 69. Lesson 70 also has to do with direct variation. But when you hear direct variation, you should think of this formula here. Y equals kx. So direct variation is a quotient of two variables. That quotient is a constant. So if we think about this formula here, y equals kx, the k stands for constant. Could we solve this equation for k? Sure we could, right? Let's think about what we need to do to solve for k. We currently have y equals kx. I want to get k all by itself. So right now k is being multiplied by x. What is the opposite of multiplying something? Well, that would be dividing. So I'm going to divide both sides by x. And I get k equals y divided by x, which is our definition right here. It's a quotient, which means we're dividing, of two variables, y and x, and that quotient is a constant. All right, direct variation, these are proportional equations. So when we graph direct variation, these graphs go through the origin, that's the point 0, 0, and they are always straight lines. So we have done these a lot, okay? Let's draw a couple graphs here. All right, is this one direct variation? Yes. Why? It goes through the origin and it's a straight line. Is this one direct variation? It is a straight line, but it does not go through the origin. So no, it is not. Right? Is this direct variation? No, it does not go through the origin. Hopefully that sounds familiar to you. So today we are going to learn about inverse variation. Please, please, please memorize this equation. Inverse variation has to do with a product of two variables being a constant. So inverse variation is y equals k over x, right? Remember, these fraction bars mean division. So y equals k divided by x. Can we solve this for k? Well, sure we can. Right now we have y equals k divided by x. I want to get k all by itself. What's the opposite of dividing by x? Well, that would be multiplying by x. So I'm going to multiply both sides by x. X over 1, k times x, k divided by x times x over 1 gives me just plain old k, right? All right, so I'm left with k over there. And what's left over here? xy. So k equals x times y. K, sorry, that's really messy. All right, k equals x times y. Could I also write k equals y times x? Sure. Whenever I multiply, the order does not matter. So this gives us our definition right here. Our constant is a product of two variables. That means we're multiplying. All right, let's look at an example of inverse variation. Miles travels 90 miles to visit his grandma. If he averages 60 miles per hour, the trip takes 1.5 hours. So 60 miles an hour is 1.5 hours. However, sometimes he makes a few stops, so his average speed varies. This affects travel time, but distance stays constant. So if we look at our chart here, our distance is always 90 because we're going to the same place every time. But our average rate changes the time it takes us to travel. So if we're going 60 miles an hour, it takes us an hour and a half, or it takes Miles an hour and a half. If he's going 40 miles an hour, it takes him 2.25 hours. If he's going 30 miles an hour, it takes him 3. So look at the graph for this example. It is a funky curved line. All right, so is this a function, what we learned in our last lesson? Yes, right? It is a function. It's just not a linear function. It doesn't make a line, a straight line. So this is what inverse variation looks like. It's a lot different from what our direct variation looks like. You will not learn how to actually graph these until you get to algebra next year. But just know that inverse variation is a curve and direct variation is a straight line. All right, let's see if we can remember the difference between direct and inverse variation. So, first of all, let's start with our equations. Our direct variation equation, y equals kx. Can I solve this for k? Sure I can. I'm going to divide both sides by x. So k equals y over x. What does my graph look like? Two things have to be true. One, it goes through origin. It goes through the origin. And two, it is a straight line. All right, let's think about inverse variation. My equation here is y equals k over x. Can I solve that for k? Sure I can. I'm going to multiply both sides by x, and I get k equals yx, or xy. My graph is going to be a smooth curve. All right, please, please, please memorize these two equations. You need to know the difference between direct and inverse variation. All right, last one. Determine if the variables in the tables A and B are inversely proportional. Explain how you made that determination. So, step one. What is my equation for inverse variation? Y equals k over x. Solve that for k. So k equals x times y, or y times x. So let's look here. Can we solve for k? X times y is 8. X times y is 3. X times y is 12. Are these all the same number? Nope. So A is not inversely proportional. All right, let's try that on B. Let's solve for k. X times y is 8. X times y is 8. X times y is 8. Are all those the same? Yes. So letter B is inversely proportional because the constant is always 8, right? Which makes it a constant. All right, there is a practice set on page 661. If you need more practice problems for these, please let me know. If you need any help, thank you.